All right, we're going to hopefully finish up this section 3 too. We talked the other day about domain and range. So what I'm going to do here is we're going to look at a graph and we're going to figure out the domain and the range from a graph. We didn't really do that the other day. Let's do a different color here. Let's go orange in honor of St. Patrick's Day, right? Okay, so there we go. All right, here's my graph right here. And let's say it bottoms out like at -10, we'll say. And yeah, that's all we need to know right there. So let's take a look at that. So what I want to do is I want to find the domain and I want to find the range. Well, what's the domain? The domain is my possibilities for my x-axis, right? Remember that was the domain, was the x? So let's think about this. Are there any values for x on this graph that will not give me a y value? Like if I picked an x right here, will I get a y value? Yeah, I'll get a y value right there, wouldn't I? What if I pick an x here? Will I get a y value? Yep. What if I picked an x over here? Will I get a y value? Yeah, because this keeps on going up and up. And you're right, it would be way, way up here, wouldn't it? Even if I go way up over here, if this went on far enough, this eventually keeps going out like this, doesn't it? Keeps spreading out. It doesn't really go straight up. It never does go straight up. It always goes over and it goes up. Always goes over and it goes up. So are there any values for x that I could not choose? No, there's not. Everything's in play, isn't it? Okay, every x value is valid. So how would I write the domain for this? Okay, we say all the real numbers, but how do I write it in interval notation? -infinity to +infinity. All right, so that would be the domain. So the domain means all my values for x are in play. Okay, I can use any x that I want, and I'm eventually going to get some value for y. What about my range, though? Now, I can pick any x that I want, but can I get any y value whatsoever? Look at the y values here. Is there any restrictions on the y values? Where is it, Alex? Good, perfect. You can't go below -10. There's no y values at all that go below -10, are there? Okay, so which y values can we include? We said the ones that you can't have. Which y values can you include? Everything what? Greater than or equal to, right? Because it lands right here at -10. So it could be greater than or equal to -10. You follow me on that? So how do we write that? So it's closed at what? -10 and everything what? Anything greater, right? This could keep on going up. So how far on the y does this go up? Infinity, right? It keeps on going all the way up, doesn't it? So it goes from -10 to infinity.
And
see that?
thank you for doing number 12 for us.
Was that the same exact thing? Oh my goodness. Oh, no wonder. I was looking at that. I was thinking I was looking at the book, and I was looking right at that worksheet. Oh goodness. I'll have to give you more problems to do since I did that for you.
No, thank you.
All right. So we talked about domain and range.
Think of it as a little St. Patrick's Day gift.
Okay, that's what I'll think of it as. Yeah, it's Morgan's birthday gift. Even though your secret stalker called my class boring, so. All right, let's do this. Let me look to see what else we got here.
Yes, I do. I'm not telling you that.
All right. What if I give you an equation, for instance, and I want you to find the domain and range, like this. What if I said y equals the square root of x minus 3? Okay, what if I said find the domain and range, watch, find the domain and find the range of this thing right here? Well, you could think about it a little bit. What are your restrictions for the domain? I think have we already done this? I don't know if we found the domain and range of this. I'm not really sure. I think we did something like this before, didn't we? Okay, let's do it again, though. Okay, what about the domain? Now, remember, x can be any number except, right, the stuff, well, x could, think of this. Right, it can't be negative, but everything inside that square root has to be what? That x minus 3. Everything inside of that square root has to be what? Greater than or equal to what? Say what it? Now, I'm talking about the whole thing, not just the x. I'm talking about everything inside the square root. No matter what you have inside a square root has to be what?
Pause.
Has to be positive or 0, okay? So how do I write that? This is everything inside the square root has to be what? Greater than or equal to 0. So let's find what x has to be. So let's solve for x. Add a 3 to both sides, so x has to be greater than or equal to what? To 3. Think about it. What if x was less than 3? Like a 2. Could x be 2? No, because 2 minus 3 is negative 1. Can you take the square root of negative 1? No. You get an imaginary number, but we're talking real numbers, okay? It's not on the number line. We're talking real numbers. So what about 3? Can x equal 3? Yeah, 3 minus 3 is 0. The square root of 0 is 0, so sure, x could be 3. What about bigger than 3? Let's try 4. What's 4 minus 1? Or, thinking ahead. What's 4 minus 3? It's 1, right? And what's the square root of 1? It's 1. And that's fine, isn't it? You can have the square root of 1. Does that make sense? So x can only be all the numbers greater than or equal to 0. How do we show that in interval notation? From where? Smallest number can be what? 3. And it's greater, so it can go all the way to infinity. Make sense? The range is the hard part on this one. Okay, what do you think the range could be? Let's graph this real quick. I'm going to say, graph it real quick? Sure, I have no idea how to even start a graph. Well, we talked about this yesterday. To graph these things, what do? Go back to Algebra 1 and do this little XY chart thing. Okay? What's that? You could, but let's take a look at it. I like everybody to visualize it so we can see why it's what it is. Okay? So let's take a look at this. Let's put some numbers in. Can you... Now look, we have a restriction though with x, don't we? Remember, x can only be greater than or equal to 3. So I can't put negatives in there. Okay, I can't put 0 in there, right? What's the smallest number I could choose for x? 3. Can't put a 1 because 1 minus 3 is negative 2. Okay, remember this right there. Our domain has to be this. So 3. I could put a 4 in there as well, couldn't I? Now I could put a 5. 5 minus 3 is 2. But let's put something in there that's going to make this come out to a perfect square. How about 7? Right? Because if I put a 5 in here, 5 minus 3 is 2. Put a 6. 6 minus 3 is 3. Can't take the square root of 3. What about if I put a 7? 7 minus 3 is 4. You understand why I put that number in? I could put any of those numbers in if I wanted to, but I would get decimal answers here. I just want to put numbers that make it look nice. So if I put a 3 in for this, what do I get? 0. What's the square root of 0? 0. Put a 4 in here. 4 minus 3 is 1. Square root of 1 is 1. Put a 7 in there. 7 minus 3 is 4. Square root of 4 is 2. I could keep going if I wanted to, right? But let's just plot this thing. 3, 0. 1, 2, 3. Let's put this in a different color. So there's 3, 0. 4, 1. 4, 1 would be right there. And 7 would be out here. And 2 would be about right there. So what's that going to look like? It's going to look just like that square root function, except, oops, we'll pretend the dot's right there, okay? It's because my graph wasn't very nice. But yeah, it's a curve like this, isn't it? Okay. Now, we already said the domain. Look at the graph. You can kind of tell where the domain is, right? The domain starts at 3, and it's everything to the right, isn't it? What about the range, though? It's everything what? Greater than, not 3. Remember, the range is up and down. The range is up and down. No? What's the very bottom of the y of this graph right here? It's 0, isn't it? See, I'm talking up and down now. Okay, I'm talking y-axis. The very bottom of this is at 0. But then it just keeps climbing and climbing and climbing, doesn't it? So what's the range then? It starts at 0 and it goes all the way up to infinity, right? And it includes 0 too, doesn't it? All right, because, right, that's a valid number right there. So it includes 0 and it goes all the way up to infinity. And that would be the range. Okay? What if we had something like this? What if we said y equals the square root of x minus 3 plus 2? Well, what happens here? Basically, we just add a 2 to everything, don't we? So instead of 0, that would be a 2. Instead of 1, that would be what? A 3. Instead of 2, that would be a 4. Do you see that? So what's our new? What if I put a plus 2 here? What does that do to my graph? Instead of 3, 0, it's what? It's 3, 2. Instead of 4, 1, it's 4, 3, which would be about right there. Instead of 7, 2, it's 7, what? 4, which would be up here. So it's the same exact graph. Oops, curves a little bit more than that. It's the same exact graph, except it raises up 2. What's the range of this one? The domain's going to be the same, isn't it? Okay, but what's the range, right? The domain, because it starts here and everything to the right. But what's the range? The bottom, the very bottom of it is 2, not 0 this time, isn't it? So the range is at 2 all the way up. So the new range, right, if I use this equation right here, would be 2 to infinity. So I think it's helpful to look at the graph. I really do. I think it's very helpful to look at the graph. It might be a little confusing, but it's recorded, so go back and watch it and try to figure out what's going on. Okay? And we got one more to do. We're going to do another graph thing here. This is not that hard at all, I don't think. I think you'll find this fairly simple. It's going to ask you another thing, not just the domain and range, but it's going to say where on this graph, what interval on this graph is it increasing and what interval is it decreasing? So let's do a I'll do one that looks very similar to the one on the worksheet that I gave you. Alright, here's a graph. This is actually an absolute value graph, but you don't really care, okay? It keeps going like this and it keeps going like this. So here's the question. It says, at which interval is it increasing and at which interval is it decreasing? Okay, so when it says at which interval, from where to where? Now, if it's increasing, what do you think the graph is doing? We read left to right, don't we? So it would be going what? It would be going up. That's where it's increasing. So it would be increasing from here, where? All the way up here. But I'm looking along the x-axis, okay? So if I'm going along the x-axis, where is the y increasing? So if I go from here all the way to where? Remember, this is an arrow. It's infinity, right? So from 0 all the way to infinity, this thing is increasing, isn't it? Okay, do you follow me? Think of this little dot just moving along the x-axis. Not moving up and down, just moves along the x-axis. As this dot moves to the right, my graph gets bigger and bigger and bigger, doesn't it? Or higher. The y value gets higher and higher and higher. So where is it increasing? From 0 to where? To infinity. Does that make sense? Let me just look at something real quick here. Yeah, we include the 0. Okay, so it starts here and it goes to there. Now, where is this thing decreasing? Where is the graph decreasing? Again, from left to right. We read from left to right. So from left to right, where is this graph decreasing? Even though the arrow is pointing to the right, as we go all the way out to where? Negative infinity, it decreases, right? As I move this way, what happens to that graph? What happens to that y value? It gets smaller and smaller and smaller until it gets to here, doesn't it? And then it starts increasing again. You follow me? Think of this dot right here as, you know, as over here like this. If I'm over here and this thing's moving along, moving along, moving along, what's happening to this? It's getting smaller and smaller and smaller, isn't it? And then I start going on this side of it, and what happens to the y value? It gets bigger and bigger and bigger. It increases. So where does it start from? It starts from negative infinity all the way to 0. Okay, so it's from negative infinity to 0. That's where it's decreasing. So this part right here is decreasing, isn't it? And this part right here is what? Increasing. So which intervals? From where to where? Well, from negative infinity all the way to 0. Everybody see that? That whole thing right there, that's decreasing. Where is it increasing? Well, from 0 all the way to where? Infinity. It's a weird infinity. But that's increasing. That's what's going on here. And that's the kind of stuff that they're asking. Okay, so you just have to write it like that. That's pretty much everything on that second half of that worksheet. Okay, so that will be due on Monday, and we'll answer a couple questions. There might be a couple on there that are a little bit harder than what we talked about today, but we'll take care of that on Monday. But give it a shot, though, okay? Try every one of these. Give every one of these a good college try, as they say.